This is lesson 48, choosing a method. So the school store sold 35 rulers last month. The red rulers cost $2 each and the white rulers cost $3 each. Total revenue for the rulers was $82. How many red rulers and how many white rulers were sold? So we can solve this by first making some equations. So we've got 35 rulers last month. The red rulers were $2 each, and the white rulers were $3 each. The total revenue for the rulers was $82. So we can come up with an equation. First, we've got 35 rulers from red rulers and white rulers. So let's say red rulers we'll use as the letter R and white rulers we'll use as the letter W. So that means we've got R plus W, and that equals, how many rulers did we sell? We sold 35 rulers. So that's an equation. And then we have another equation. How much was the red ruler? The red ruler was $2, so that's 2R plus, how much was the white ruler? The white ruler was $3, so that's 3W. And what did we sell them for? We sold them for $82. So that's our second equation. So we could, what method do we want to use to solve this? We could solve for a variable and substitute, or we could solve, or we could make opposites. So let's do both. We've got both of these equations. First, let's do substitution first. So substitution, we could take this top equation and solve it for, let's solve it for R. So subtract W from both sides, and we say R equals negative W plus 35. And then we could take this value of W and plug it in for R. So we say 2R plus 3W equals 82. Then we're going to substitute in a negative W plus 35, and we'll get distribute negative 2W plus 70 plus 3W equals 82. Combine our like terms and we'll get W plus 70 equals 82. Subtract 70 and we get W equals 12. If W is 12, we can substitute it in to this equation and get R equals negative W plus 35, and we get, substituting in a 12, so we get R equals negative 12 and 35 makes 23. So that's 23 red rulers and 12 white rulers. That adds together to make 35 rulers total. So that's substitution. We can do the same thing with elimination. So our equation again, R plus W equals 35, and 2R plus 3W equals 82. And we can see that if we multiplied this top equation by negative 2, we'd get negative 2R minus 2W equals negative 70. And we don't need to do anything to this bottom equation because we already have a 2R, which is the opposite. So we're just rewriting this bottom equation. And now when we add them together, we get W equals 12, And we can substitute that back into this top equation and get r plus 12 equals 35. Subtract 12, and we get r equals 23. So that's, 23 reds and 12 whites. And we can see that both equations will give us, or both methods will give us the same answer. And we also notice maybe that that combinations is quite a bit faster than substitution. So I like to use combinations. Sometimes I use substitution. If we're already solved for a variable, I'll use substitution. But that's what you guys get to choose in this lesson. Here's another problem here. It says we're going to race a horse, and we can run 2 kilometers every minute, and the horse can run 0.2 kilometers every minute, and the horse can run 0.5 kilometers every minute, but it takes 6 minutes to saddle the horse. So how far can you get before the horse catches you? And we can see that this says distance is on our y-axis, is distance, and our x-axis is time. So distance and time. So let's come up with an equation. We're running 0.2 kilometers a minute. So time is in minutes and distance would be in kilometers. So our equation would be y equals 0.2x. Well, that's hard for some of us to do. So what is 0.2 as a fraction? Well, 0.2 is 2 over 10, right? So what is that? That's 1/5. So that's the same as y equals 1/5 x. And that might be a little bit easier for us to graph. We're starting at 0, time 0, distance 0. And we're going up 1 and over 5. That means if we're running 0.2 kilometers every minute, that we're going to run 1 kilometer every 5 minutes, 1/5. So up 1 over 5 again, and we've got a graph of our line there, y equals 1/5 x. Now the horse, what's going on with the horse? The horse is running 0.5 kilometers, but it takes 6 minutes to saddle the horse. So again, 0.5 kilometers, that's its slope, would be 0.5. Well, what is 0.5? 0.5 is also 1/2. So we know its slope, the horse's slope is 1/2, but it takes 6 minutes to saddle the horse. So instead of starting at 0, the horse has got to start at this point out here at 6. Well, we know its slope is up 1 over 2, so it's going 1 kilometer every 2 minutes, 1 kilometer every 2 minutes, 1 kilometer every 2 minutes. We could finish off this graph by just going down 1, left 2, down 1, left 2, and we could see that our y-intercept, our b value, our y-intercept would be -3 here. So that would be the equation. That would be the equation y equals 1/2 x, and where y-intercept would be -3 minus 3. So, but let's say we didn't have a graph with us, so we just had to do this algebraically. What would we do if we had to do it algebraically? Well, all we'd know was that we were starting out here at this point, which is 6, 0. And we also know that we have a slope of 1/2, so we can put it in point slope form. Y minus y1 equals m times the quantity x minus x1, and we could substitute in our value of x and y into this. So y minus 0 equals 1/2, that's our m, times x minus 6. I'm plugging in the point 6, 0. Well, I can write that in slope-intercept form by distributing my x. What's 1/2 times x is 1/2 x, and 1/2 times -6 is -3, and y minus 0 is y. And we can see, hey, that's our equation. And then to answer the question, how far can you get before the horse catches you? We're meeting, these two meet at this point out here at 10:2. So that means we're going 2 kilometers in 10 minutes. So the horse will catch us in 10 minutes. The horse actually catches us in 4 minutes of it running because it starts at minute 6. But as far as we're concerned, we run for 10 minutes and we get 2 kilometers out there. So there can be many ways to solve the equation. What have we learned so far? We've learned to solve by graphing. We've learned to solve by substitution. And we've learned to solve by elimination. And we also call that combination, because we're going to combine our equations to eliminate a variable. And today's lesson is lesson 48.